folks. This is me, Vishwas Nayan. I'm the host of this podcast. A lot of times we just complicate things, right? We want serverless in our application. We want whatever gets attached to the new technology, we just want them in. But there is a whole new level of complexity that you need to deal once you think what's your business prospectors are saying in the boardroom, what's happening with respect to the architectural practices. And also, you can't just keep paying a cloud service provider, but I think you need to evolve in terms of your practices because I feel if you want to really win the game of technology, the first thing is this technology that we are using might be something that is getting fancy today, but it's going to evolve. That should be your own mindset. And I think Rajat sir is one of those people that I look back at because the day he talked in Azure Developer Community, Azure Dev Day, I was like, you know what? There is nothing complex in the world of tech, but you need to evolve accordingly because Intuit is one of those biggest customers to the AWS, but fundamentally they're also evolving with respect to bringing their own tools, bringing their own practices. And I feel even in the slides, they had some sort of practices being taught. And I think let's just demystify something more with Rajat sir. Let's discuss his journey as a cloud professional to the learning that he had throughout his journey. So thank you so much, Rajat sir, for being on the show. Means a lot.
My pleasure. Thanks a lot for having me here.
Sure, sir. Let's get it started. So, what was your journey as a cloud professional, and how did this industry grow with
Yeah.
your experience? Like, you have, I know for sure you have also seen mainframes and also broken
Uh,
production monoliths. So, what is it all about with your journey as a cloud security professional or cloud professional?
sure, sure. So, and I just want to recall back about a couple of decades when I started my career, perhaps in the late 90s as a student, and then of course early 2000s, a time of dot-com boom, and a time of a lot of uncertainties with the 9/11. That's the starting of my career. And if I look at the times there in terms of the fundamental problems, one thing I have seen recurring as a pattern is the commoditization of what it requires to accelerate technology evolution. By that I mean is when we were all C++ developers, possibly coding for the mainframe or even Microsoft applications and so on, there came a barrage of tools which helped us get progressively better. We had frameworks to work upon. Remember MFC and .NET and DLLs and all of those things that came. COM came as a common object model when components couldn't speak to each other. And why did they come? Because there were some problems in accelerating the speed and velocity with which we could build software, with which we could build a reliable software. Then came a world where we started moving away from primary native languages for especially business applications and moved towards more managed frameworks like Java and .NET and many other such managed environments, right? So it took away a lot of those concerns like memory leaks and pointer management and so on. And why again did that happen? In order to fundamentally solve the problems that came in the way of engineers, of developers to build great quality software. Now, I fast forward 20 years to here, I still feel that the basic premise is the same. When we as a technology community hit upon something that truly can empower us to move faster and solve bigger problems for humanity, for our customers, for all of us, the innovation happens in that space enough such that it makes it easy for the larger engineering community to solve that. And that really is the power of a very connected, globalized engineering and developer community, so to say, which has really democratized the way any new innovation can really spread very fast. So talk about cloud, I think late 90s or early 2000s, we saw the emergence of AWS or other cloud providers. By the way, hosting was not new. I mean, we started having providers like GoDaddy or all of those right from early 2000s, providing hosting, content management capabilities, and many others. But at scale to have innovative capabilities that allow us to solve for compute, for storage, for processing, for notifications, all of that is truly where AWS led the innovation. And why did they do that? Because they could clearly see that by that time, large organizations at scale were struggling to build and host and manage their data centers. They did not have the right expertise of talent to run that at scale and with quality. And therefore, they were struggling to make that happen. And that's the opportunity space that they attacked at. Truly, again, going back to my example, to solve some burning problems that the developer community had, which if taken away from their eyes, would make them order of magnitude more productive. And that truly was the real reason why AWS became so popular, say between 2010 to 13, 15, and saw such massive adoption, because it made complete sense, right? For you to be having a reliable hosted solution that manages your compute, your data, your storage, your various other capabilities, and you focus more on building your applications and your capabilities, right? And therefore came a huge discipline that we now call as DevOps or SRE, to your point, or cloud professionals, who were in the service of making sure that as a mindset shift, as a culture shift, and as well as an infrastructural shift, the organizations that had invested millions or billions of dollars in building their own data centers or hosting sites in the previous decade, which is 2000 to 2010, could be enabled into this journey, could be smoothly brought over. And therefore, if you would recall, most of the early adoptions of cloud were more lift and shift, as I call it. People didn't fundamentally wanted to completely change their applications and services. They wanted to make sure they take benefit of the cloud. They benefit from the cost model, being able to scale up and down things over a night or a peak day or a Christmas day and so on. But they didn't want to fundamentally rewrite their application. So that was the first wave I observed, and I have been a part of that in my organization, where it was a prudent shift. It allowed us to learn a lot, and that's where I think the true power of what we call as operations people in our teams evolved into the disciplines of DevOps and SRE, because these were the experts who had spent a ton of time managing network infrastructure, product infrastructure, data centers, and soon they were the most sought after professionals, because they were the ones who could ease the journey from moving to in-premise hosting to AWS. And I think most of these are the ones which today we recognize as experts in that area, because it brought in a lot of their practical learning and hard challenges. And possibly many of them joined AWS or Google Cloud Platform to help solve those problems once and therefore be able to benefit others. The next key journey in the evolution I see is the period, say, between 2015 to now, right? All right. Uh, Adoption of cloud became table stakes. Many new startups or new tech companies that were born in the last 5 to 6 years never even know what a data center is, because they just directly started in AWS or in Google or whatever cloud providers. And they grew from there. They natively started using those capabilities. And then comes the next generation of problems, right? Before you know it, your team or your organization probably has 5 big monoliths, and you have that challenges. And when you federate and open up the gates, you soon realize that you have 500 services and 500 AWS accounts and 500 ways to release patches and AMIs and all of that management and federation. And there was born then therefore the next problem of how do you manage this cloud infrastructure at scale? How do you make sure that things when have to be governed in an organization, whether it's security patches or vulnerabilities or updates or other software upgrades and so on, we could do it at scale and manage that. It became horrendously hard, and before you knew it, and I could speak for again myself as a part of that experience, that as soon as we shifted some of our biggest applications to the cloud, it all went great. But guess what? The next 3 years was like, even to onboard one new service to AWS would take 2 to 3 months, because everything that like a set of expert team of probably 20, 30 best experts in the team did for this big monolithic application with say 10 million customers, would you be able to afford that for one microservice that's going out and the second and a third? No, right? But guess what? As a trusted company, especially dealing with financial data like ours, you had to have the same rigor. So there came like 140 checklist items which would have to be done by every team before they go live. And that meant that even if I had my code ready, it would take me 3 months to ship it. And that was this time when the next generation of innovations like Docker, like CNCF, like Kubernetes and all were just forming up to really solve the next generation of problems. Yes, you have gone into the cloud, you have a lot of capabilities and services, but how do you manage it at scale? How do you make sure that you make it cookie cutter and common problems even on the cloud are solved once, so that many teams can take care of it? If you have to roll out capabilities, you're not like literally replacing it, but just working across these. So that's where I think this next generation of innovation came, which we continue to see here. And that is where, as you see more and more, again, I recall the example of commoditizing of the problems. Because there was a burning need for the cloud, because the adoption had gone big, therefore there was a need to solve these problems, and then they got commoditized. Today, in the more recent last few years, we've seen the same thing happen with data science and AI and ML. As these capabilities also have gone to the cloud, it is no more required for you to write down literally a complex ML model or an algorithm from scratch. Most of these are available as services and libraries on the cloud. So my learning over the last 2 decades has been, whenever important problems surface up, when there is a critical mass across the globe that is facing those problems, the technology community comes together and comes up with a solution for that. And the world of DevOps and SRE is just an outcome of that, which has empowered every single developer to be able to take care of their code and take it to production. And they have become more facilitators than the gatekeepers.
Yeah, I feel that. I feel that because we still came out with a lot of Ajax and things like that. So when I ask them, they tell me, what, Vishwas, we never had something like Kubernetes on our own thing. It's still Unix to me if I look at it. So to me, when I see somebody like, what, in a conference there are hundreds of talks coming out with DevOps practices, I feel that, there is somewhere down the line, it's a missing piece of a puzzle in the world of technology. That means it's been misunderstood to a greater extent. So I wanted to understand, is DevOps a complex piece of puzzle for an organization today? What do you feel about the way we are building the tech? Because fundamentally, it's like a cloud service provider gives a well-architected framework, and everybody wants to metric out of it. Like everything comes back to that only. So what is it all about when we are doing adoption at scale?
Yeah, I think great question. So as you rightly said, right, there is hyper innovation, as I call it, happening within the cloud service providers, because there is now great competition between Azure and AWS and GCP, some of the three leading providers. So they themselves are commoditizing and continuing to make it more and more easy for the developers to consume their services directly. But then comes a problem of organizations that have a certain scale, say they have a few hundreds or thousands of developers. How do you make sure that humanly and possibly across geographically distributed, how do you make sure that they are able to consume these capabilities in a consistent, repeatable fashion, such that when engineers go from one teams to the other, they don't find things are north and south, and they are able to accelerate by not having the same problems to be solved all over again. So that is where what I have seen is that the discipline of DevOps, or some people, some teams, organizations now call it as DevX, which is how do you enable the right developer experiences to ultimately have the developers, the Scrum teams, or pods, or various other names that we call, who are ultimately building code and shipping it, are completely accountable for all aspects of it. Writing the code, designing it, testing it, deploying it, observing it post production, and making sure they are complete custodians of the license. That has become the focus. And in order to enable that developer experience, now DevOps and SRE professionals are more part of such central teams who are making sure that it's been a while that I have seen the presence of a lot of DevOps and SREs in every Scrum team or every small organization within a big company, right? They usually now are a central team of experts who always are ready to lend their helping hand should you require it for a customized problem. But they are more investing in solving problems at scale, such that if you have once solved it within your Kubernetes infrastructure, the way auto scaling should happen, or the way replication should happen, or the way fault tolerance should happen, you are immediately enabling at the click of a button hundreds of Scrum teams who will use that infrastructure to deploy their services to get that right. So that's where the true value of DevOps and SRE has come, where most organizations that have understood it now have thoughtfully invested into a small, focused, but very critical DevX team, whose whole sole responsibility is to liberate and make the job of hundreds of other engineers super simple. So if you want to spin up a service, it should now be a matter of 3 clicks. If you want to spin up a web experience or a mobile app, it should be a matter of a few clicks and your entire scaffolding is ready to go. And what does it take to give that awesome experience is what the DevX teams are about. And you will always have an exceptional case where you need a helping hand, and they're always here. So what this really means is that the practice of DevOps, just like a few years back, now we don't even recognize the difference between a developer and a tester, right? They just have come together. Likewise is now the case. The engineer is the developer, he is the tester, he is the DevOps, and he is the guy who's going to observe and monitor what happens. And in this process, he will get the right tools. Again, the commoditization of development has happened, whereas his job is focused on his day-to-day business problems rather than a lot of infrastructure. So that to me is really the focus of DevOps and DevX, where it will continue to focus on niche problems, and smart organizations will invest it in such a fashion that a handful of experts invest into understanding what's happening in the space outside, bring it into the ecosystem, and make sure every single engineer in their organization can adopt it really at scale.
Yeah, I always believe that, customers want everything to be just like an well-oiled machine. They don't care about the money that they are paying to you, or else they don't want to go through the complexity. Because I don't care whether you do it monolith way, serverless way, or else you are deploying it on Kubernetes. Guess what? I'm paying you the money. I'm giving you everything. Can you give me that sort of an accessibility in such a way that I don't want to understand the technical aspects of it. I just want to use it according to me. Like an accountant wants to just do a calculation. Like like Intuit is an amazing tool, right? It's not just a tool, it's just a platform where you have hundreds of customers from various organizations and also various practices as well. So my question is all about getting that right developer experience is good, but the way in which world is also adapting towards the SRE practices, and also there are some anti-patterns which are getting developed. That means let's do what Intuit is doing. So we'll win in the game of the technology. Guess what? Their customers are not yours at the end of the day. So I wanted to know, how is the developer experience and the customer experience just going to be solved in the world of, that is just talking too much AI, but I wanted to know, how can a developer really evolve in an organization by eradicating most of the DevOps anti-patterns that we are seeing today? Because today's organization culture is just going way beyond the reach. So I just wanted to know, what is it all about when we are talking about building against the anti-patterns of the DevOps, and how can an organization culture also evolve accordingly? Because Intuit as an organization has set an example, but like, how do you feel
Yeah.
that a startup can also be an impactful journey in the world of DevOps?
I think a good question. I'm just trying to relate to a few practices that I have been driving in some of our teams. So look at it this way, right? Just because you have a very powerful engine and a very powerful tool, and then therefore you never know what happens behind the scenes and how does it work at all. There will come a day when your car will break down in the middle of the highway, and you would have a problem to even diagnose what happened, right? So you would have then have to call somebody to come and rush and help you out. So the analogy that I adopt here in terms of engineering and software development is that we should push for our organizations to invest more and more into the right developer experiences to solve the common problems, to solve the common anti-patterns. But that doesn't take away the fundamental need for engineers to be well aware of the basic concepts of computer science, basic concepts of software development and great code and great design. In this today's world, the concepts around distributed systems and their interactions, because uh, they are not being taken away from you. So the myth that we have to clarify in the minds of young engineers and as well as expert engineers is that great tooling and great DevOps infrastructure is there to solve our problems, but not for us to become agnostic and blinded by what's happening. So I still encourage engineers in our teams to deeply study and understand the basics of great software development, great object-oriented design, great design patterns and anti-patterns like you called, and really hone that craft. In doing so, what will happen is they'll find adaptations or implementations of that in our own DevX fabric, as I call it, and they'll say, "Oh, okay, right. This is how they have implemented resiliency or redundancy or caching in the way things were done in my organization's DevX." But to always think that, hey, something will be happening behind the scenes. How do I care? I just clicked and created my application and everything is great, is not the right way to think about DevX and DevOps. We should think about it as that here are the, there's a concept called 12 factor app, which I like as a framework, which allows you to think about the basic 10 to 12 fundamental aspects of building great software. I think the engineers should still be very proficient and invest time and energy to learn that. Imagine that the DevOps tools are just coming in, that once you are understanding those concepts really well, the tools will help you accelerate your journey. But we should not look at it as, hey, our problems have been solved by somebody else, so let me not just worry about them ever. That will not lead to the right engineering culture and the right questioning mindset. And guess what? Who are the customers to these DevX and DevOps teams? The engineers, the developers, right? So only when they are reasonably aware of the possibilities, which will only happen when you study enough and inquire about, hey, what can happen, say in Kubernetes, right? It's a vast field. Some of our DevOps and SRE engineers are experts in that. But who are the consumers of that? The engineers in a Scrum team, right? So they have to be reasonably aware of Kubernetes to ask the right questions and push the boundaries and say, hey, I would have desired a certain way for me to provision my pods or scale up my clusters. Only then those DevOps teams would get, okay, this seems to be a business requirement. Let's go ahead and figure out how to do it at scale. So the responsibility of engineers and software developers has actually increased, because unless they question hard and bring the right problems they are facing to the table, like I used the analogy during our discussion, the next wave of commoditization will not happen. How will the next set of problems be solved? And this cannot happen with passive engineers, right? Who are just there, hey, I have a problem, but who cares? Let me just do my work and go away. It can only happen with active engineers who are studying, who understand their ecosystem. So that's the practice that I love to encourage the engineers to think about. DevX and SRE is not about somebody has taken your problems away. It is about you being more conscious, because ultimately you are accountable for the delivery of your service.
Sure. In your Azure Dev Day talk, you talked about happy monoliths, and that's something that we didn't actually expect in that talk because it was all towards the SRE problem statement that we are actually looking forward to, or else what is Intune
Yeah.
doing. So I wanted to understand, like, SRE is kind of an operations problem statement to me, because I know for sure you look at different matrices of SLI, SLAs, SLOs. Though SLA is being evangelized more, SLI and SLO is not something that is being evangelized too much these days. So I feel that it's a value of treating a problem statement just like an operations problem statement. That's what SRE is. But like, I wanted to know, SRE practices are good one way, but like, how can an old architecture, or let's say an engineer like me who wants to get inside the industry, but you said about happy monoliths, what can happy monoliths teach to me in order to evolve with my SRE and DevOps practices? Because fundamentally it's all still the same.
No, great question again. So let me share this way, right? That how did something become a monolith? Any product that today is a monolith, first of all, we should approach any monoliths with a sense of due respect and regard, because the reason they are a monolith and they are still around is because for certain years, or hopefully decade or more, they have been solving some critical customer problems and they have made revenue and business. That's why they are still around. Otherwise, that would be a scrap piece of code and those people will not be around, right? So the reason that something is a monolith is because over a period of time, it has solved some critical problems. And then therefore we should approach it with a sense of respect. I see certain teams that, hey, it's a monolith, so everything is bad about it. No. Uh, like some of the engineers who build these applications and systems over a period of time are some of the most fantastic engineers. So would they have been like crazy enough to end up being a monolith? It is a lot of context and historical, sequence of events that leads the source code and something to become a monolith. So first we should approach it with a sense of respect and learning, that what's going on there, what can I learn about it. Secondly, we have to understand that the world beyond the monolith, the so-called microservices architecture, or some of the new paradigms of software development that have been quite popular in the recent times, are not free of problems. There's no such thing as free lunch there. In fact, if you're not careful enough, you can screw yourself much more. You can have a lot more bigger problems in the way various services interact with each other, the failure points they introduce, the performance of the systems, loss of data, and many other such critical problems, which are very difficult to reason with. So when I talk about happy on monoliths, I talk about a middle ground where you do have a reasonably large size of code, but with due set of principles, patterns, and a discipline in the team, you have kept it in a healthy state. It's easy to reason with. It's easy to navigate across the flow of the code, even if, say, let's say it's a million lines of code. If there has been enough rigor done in terms of how it is organized, how it is partitioned, other pieces of that it is well owned by certain smaller teams, it actually is helping you solve some problems that you're about to get into when you break this down, let's say in 50 microservices, right? So that journey should be motivated by various other reasons, like how your organization is scaling, how your customer base is scaling, how your domain model is scaling, right? Those should be the reasons for us to move away from a monolithic architecture into smaller capable services, and should be driven by very clear return on investments, not by just a jazzy architectural vision that says that, hey, let's break this into 50 pieces, right? Those 50 pieces might likely lead to 100x problems. So I have seen that in the middle of this is what I refer to as a happy monolith, wherein the teams have done the right rigor, discipline, and engineering investment to keep that monolithic application in a healthy state. It is continuing to solve problems at scale, and it is avoiding you to embrace still a bunch of problems that you will end up facing when you break this down into smaller services, right? And it has worked out quite well. There will be a tipping point for any large monolith beyond which we have to look at certain pieces of that as business needs evolve to break them down. But the motivation for doing them should be the right business outcomes, the right productivity and efficiency outcomes versus the sanctity of the architecture, right? So that's what I mean by monolith architecture. It's a well-defined piece of code that has solved important customer problems for years together, is hopefully helping organizations earn millions of revenue, and it still makes sense to take good care of it and make the developers who work on it happy.
Yeah, like, once I talk about something like Kubernetes, it's a talk of the art. Like, nobody talked about Kubernetes more than what we saw after the pandemic. Because I still attended the talks of Kubernetes in 2017. I still knew that there's the fact that, there is going to be an adoption that is going to shift. It was just like the TensorFlow for the world of microservices. That's what I feel about Kubernetes. So today I feel that software engineering practices are evolving, but we are yet to witness something more beyond the available states, because Solomon Hikes came up with the Docker and it changed the way we are thinking containers today. So, in a meanwhile, how did you witness some of the changes in the software architectural patterns that you're seeing today? Because fundamentally, it's all monoliths, it's still the same old code, it's optimized, it's artifacts at the end of the day. You deploy it somewhere. But what are the software architectural practices and methodologies that are changing? And you can also give in terms of like how Intuit is approaching this kind of a problem statement.
Yeah, sure. So I think one aspect that I think I was giving a couple of examples before is that we have started looking at, because now we have embraced the cloud as a fundamental premise from day one. We don't even now talk about any of our capabilities being an in-premise, right? So we talk about most of our things built as a collection of services which work together, right? A few aspects of architecture that become enablers to make that happen is, how do you bake in some very standard principles, patterns, and constructs like we were referring to a while back as a part of your architecture definition, right? So fundamental aspects of defining clean, decoupled, well-defined components as a part of the architecture, those concepts never go away anywhere, anytime. But to complement that, we make sure that as a part of the architecture community, we encourage certain standard problems that we have seen and faced and solved for to be brought in front of a new team on let's say the first few days and weeks that they are going to go ahead and solve it. So they actively think about it. And by that I mean is, when we know that we are working in distributed world in cloud where multiple services and systems are going to interact with each other, how do we actively think about not just solving for that functional use case? When you're solving for the functional use case, how can you more and more think about reuse? How can you think about what is already available before you reinvent the wheel? Both within the cloud infrastructure, within the say a provider like AWS or GCP, and as well as in your organization. So how can the architecture help you first go and look out for, if you're looking for a search algorithm, if you're looking for a way to do caching, if you're looking for a certain way to solve other common well-defined problems that have been solved in the industry or in your organization, how can you have an easy way to access them? Because unless, like every team will have deadlines and business pressure, unless you make it super drop dead simple in days or hours to discover existing things, guess what? If a developer has been given a timeline to deliver something in say 4 to 5 weeks, which is a very reasonable timeline these days, he will end up going on his own, because it's in the short term, it's always faster to go on your own. If you tell, leave me alone, I will like to solve the problem, I like it, and I'll run fastest in it. But guess what? It will take me, the sprint will be fast, but then you will really get slowed down because I'll have to manage and maintain all parts of it. I wouldn't have thought through all aspects of it to take it to scale. Versus if I stop and see what is already out there, and then you approach it in terms of solving your problems as a part of those building blocks, and it's easy to compose and assemble them and test them. Not only with my short-term delivery will be actually accelerated, I am building on a durable foundation. So one aspect of two aspects of architecture that have become popular to help facilitate this way of thinking is a domain-driven architecture, where you look at your entire organization and the space of problems you're solving as a company and divide your space into what we call as certain discrete, well-defined capabilities that map to certain key domains. In the case of Intuit, it could be accounting, it could be tax, it could be small businesses, consumers, basic things that every organization needs, like identity, billing, federation, document storage, all of that, right? So when you dissect your business outcomes in terms of a map of capabilities, it now becomes easy for you to define any new problem you will solve as a composition of those capabilities. You don't start in the vacuum. You study your cloud providers, what are they providing? You study your own company, an organization, and think about the domain that you are going to solve the problem. Has it been really unsolved? Has somebody else solved it? Is it really truly unique to your domain problem? You don't want to solve an infrastructure problem of hosting or replication, or that your DevOps team or DevX team that I talked about should be solving. If you as a capability team, let's say, are building a new capability to do tax filing, right? You should truly be focused on that domain problem. And anything else that comes in your way, your first approach should be, hey, has that been solved? And that is what is facilitated by this more capabilities-based thinking, or a capabilities-based architecture, and supported by a domain-driven design, right? So you define your entire organization as a set of key domains. That helps that thinking of reuse, of composability. I think the second aspect of it is, how then do we create what I call as paved paths? And I referred to that during the conference as well. So how do you make sure that for a given nature of category of problem, first of all, we dissect the common problems that engineers will come across in terms of solving into some class of problems. And for each of them, can we define like a paved path? Some examples could be that, hey, I'm going to start writing a scheduled job that runs certain processing in the back office to process certain millions of records overnight. This is a class of problem, right? To run scheduled jobs at scale. Another problem could be, I want to implement a publisher subscriber infrastructure, which is based on, say, a message bus like Kafka. How do I do it at scale and make sure my publishers and consumers are reliable, guaranteed, there's no message loss? This is one class of problem, right? How do you build microservices, as I was saying? How do you build web applications at scale? So when you identify the class of problems that your engineers will come across, how can you bake the best practices into one place and one reference point? Not just as some big document to read, yes, of course, good case studies, but also code that can be picked and reused as a scaffolding. So if I want to start a new web application, it should take me 10 minutes. And every possible learning that Intuit has had over the last 10 years of writing a kick-ass great web application, you should just come to me. That is when you have achieved the architecture scale that we're talking about, right? So that's then the next pattern, where we think about defining paved paths in the architecture, where well-defined problems are solved once and made available for everybody, so you can leverage from that. So I think these are the things that come to my mind. Always think cloud native. If you have embraced cloud, look at what's available out there. How can the capabilities in the cloud help you to move forward? Never look to solve problems that may have been already solved by you or in the industry. First, study that and do that build versus buy kind of analysis, and start building something when you truly are adding value, which is an unsolved problem out there.
So yeah, that's a great insight for me as an engineer. But today we are approaching everything as code, something like policy as code, governance as code. And of course, like when I see AWS, I think the IAM practice that they are getting in for their customers with respect to policies, and also in terms of getting that access to the right people, I think that's a huge challenge for me. Like I think AWS solved that. But I wanted to ask, now we have policy and governance as code, but how much is that tech going to be influential in the tomorrow's world with respect to an DevSecOps practices and all those aspects that covers up the security practices that we want in an organization? Because fundamentally, your product manager might not know what can go wrong down the line, right? He can be a person who can be a victim to compromise some of the credentials out there, or something like we might give our APIs that we created in our company to somebody as a third party tool or a third party builder to just give me that Android application or iOS application, because that's what some companies are doing today. So how is all these practices like policy as code, governance as code, and anything as code, that is what we are coming up today, going to help and impact us in the DevSecOps practices?
No, I think great point. Again, I allude back to the same analogy that I was talking about. Since it's a common problem that would be required to be solved well for every application or service that you build in a certain organization, the right prudent way to do it is to have a team that is invested into it, which is at the forefront of the vulnerabilities, the problems around security that will come up or are coming up almost on every single day, and make sure that it creates a way for those to be adopted and addressed by the larger developer community with ease. So it starts at various levels of adoption, right? The first step comes in that when you're starting something, you're starting an application, a service, or a new capability, how do you bake in the right security guidelines and practices right into that? Which means that when I talked about, hey, I create a scaffolding of an application that creates a microservice or a web application or other such things, how can I make sure that the right way of securing my vulnerabilities, the libraries that I refer to, any open source libraries of Java or Spring that I use or any other things are a standard set that are well vetted by a central team. Any coding practices that I use in the way I should be structuring my code or opening up ports or infrastructure and applications are well baked into that scaffolding that gets created, right? So how can you bake things up on day one when you start? Now you start building your things on top of it. So of course, over time, you may have a solid foundation, but based on the nature of code that you write or the design and infrastructure that you create, it may open itself to vulnerabilities. So how can I make sure that as a part of your CI/CD, as a part of your right DevOps practices, you bake into your pipeline the right tooling that allows you to detect any security vulnerabilities ahead of time. So be it tools like Contrast Scan or others in that ecosystem are something that we deeply adopt and make sure that when I am setting up my code and I'm setting up my pipeline, there are these fundamental security runs that are automatically a part of it. So the moment I spin up my service and I deploy my Jenkins pipeline or other such things, there are going to be steps introduced into my staging and QA environments that the moment I push my pull request, it will run certain set of security scans and report those findings. And some of those findings based on the severity are things that you cannot just skip. You cannot merge your code. You can't deploy your code to production till you solve for some of those. So these are the ways you enforce certain things by guardrails, right? You can't just go ahead and deploy something and later on discard. So this is the second phase I talked about. First is you start with a solid foundation. The second is that while you are developing, how do you make sure that you are well aware of what could you have violated and you detect it within your code, within your staging environment. But given this velocity and speed with which any kind of vulnerabilities are being detected, reported, and exploited today by the larger community, you can always have things that go out in production and still have certain vulnerabilities that you catch. I think that's the places where we inject the right set of agents that we could run in on our hosts. I call the hosting as so think of a Kubernetes pod or a Kubernetes image that I have deployed, say on a Docker image that I have deployed on Kubernetes at scale. How can I have the right agents installed in it, such that if I detect certain vulnerabilities of a kind that is either having a DDoS-like pattern or a way in which there is data being captured, which is not the right way, or if I'm losing certain kind of things, or there's kind of some kind of injection happening, there are these patterns of uh, attacks or hijacks that could be detected in production. So therefore, we invest there and make sure that in our production deployment, in our images, there are those agents running that are able to detect such vulnerabilities and report it. Having had these benchmarks was not there on day one, let me say, and for any organization, when I say it's not an easy path that you just get, this is all coming with experience and the hard learnings that the various teams have had when they've actually faced issues and they've been suffered because of that. But then the right way to think about it, they've brought that back in the service of every single team, because guess what, security vulnerabilities hardly happen in isolation. When they attack, they impact every single service that you have in your company or in your community, right? Say even if you're in open source. So the right thing to do is to detect it, to bring it back and solve it in a way that it can be applied by everybody else in the organization. Thirdly, I think apart from the right foundation, I talked about the right tooling as a developer and in production, nothing takes away the value and importance of training on security principles and challenges at scale. So which is where I think to your point again, then the value and importance of some of our DevSecOps experts and all the great stuff happening in that field is because then we have like a standard red team who is investing into building that infrastructure and providing that guidance, but also periodically sets up mandatory trainings that we have all got to undergo, which helps us understand how to address these things should they come up on one given morning or evening and so on, right? And how do you systematically go about troubleshooting it and addressing it, talking about it in the public forums, and how to systematically address it at scale. So I think it's a combination of these four factors: build the right foundation, give the right tools and to your engineering team so they are not introducing vulnerabilities in the first place. Thirdly, if they indeed are introduced or there is a new patch that comes up, how can you address it at scale and remediate it? And fourth, complement all of this with standard thorough trainings that are repeatable and happen time and again. So I think these are the ways which we can address some of these security challenges that we face today.
Yeah, that's true, because you need to be a student of your own production system that you have built today, because that's the way that you just evolve over a course of time, and that's the way you just give yourself that future challenge that, you know what, it's going to evolve, don't worry about it. So I think thank you so much, sir, for your time, and also for such great insights, by the way. It means a lot when once you are facing a lot of production issues and you have learned from it and you are giving that insight for us, that means we are actually building ourselves as the best version for the industry for the tomorrow's world. And thank you so much for such grateful insights. Means a lot.
No, thank you again. I appreciate you reaching out and setting up this time. And
Sure.
would love to engage in other such interesting topics as well.
Sure. Thank you so much, sir. Thank you so much.